So welcome at Ask the Professor. I really enjoyed that you have questions to me, and I'd like to give you answers personally. I think it's a really lively discussions on the fora, and we try to give you a personal answer in the group, or what we do now when it is more general. I like to discuss with you with my pleasure. So let's see what we have on the Harvard of the questions. So what I saw in the fora is that we have some questions about profiles, and therefore I like to zoom in what are the questions of the profiles. For example, what is the difference between 54E1 and the UIC 54 profile? Now when you look to the profiles, it is the same name, but the old one is because of the normative at the UIC with a society of all infra managers together, and they have technical normatives, and they called in that normatives a profile UIC because of the UIC community. And what we see at the 54E1, this is the European normatives, and therefore we have also this new naming of profiles. And is there any difference? No, there's no difference, because the profile we had in the past, this 54E1 profile, is just the same. So the same shape, the same profile as it was in the old days. Then another question was, okay, what about the profiles E2 or E4, E5? So what about that one? So the 54 profile is because of the weight of the rail. 1 meter of rail is 54 kilogram, and therefore we have this 54. When you go for the E1 or E2, that means the differences in shape, and that's the differences of the shape of the profile. Minimum differences in the foot and the body, but more on the head, and that's because of the mixture between wheel and rail. Therefore we have these different shapes like the radius 18, 30 and 300, and that's a difference that makes the differences between E1, E2, etc. When we go for the next question is what will happen when we have a higher rail weight, so a bigger rail, and that means a more stable track, and that's for sure, the answer is yes, and therefore a higher speed can be allowed. But that's the question mark. Is it really the difference that you need a higher rail weight to have higher speed? I think it's a mixture between the load and also the dynamics you have when the train is running over a rail, and therefore the question should be, is it desirable to increase the height of the rail when the speed increases as well? And I like to add something, because what you talk about is when you add a higher rail, that means when you have this 54 profile and we go for example 60E1 profile, you see immediately the differences, because you can see this and you see that the height is higher, and also the foot has a bigger foot distance. So it's higher weight because it is bigger, and you see the bigger the shape over here. That means a higher height of the rail profile means a higher resistance against bending, and that means that you have a higher resistance of bending. So you have a different different wire, you could say, which is pre-stressed because of continuously welded track, and it's like a guitar. So you give a different sound. And this frequency you hear gives also a problem with the wheel-rail interface. So when you have a higher rail with a lower axle load, then you get problems with corrugation. And that kind of defects you see more in countries when they use 60E1, or what we have in Holland, in the Netherlands, then you see this 50E4. So that's more or less the differences, and also the relationship between the weight, the frequencies, and also the speed is not that important, it's more or less the load. Another question, that's about, is it always wanted to know what are the reasons behind defining the minimum rail length? And I think you mean, what is the minimum rail length is, what is the minimum size of one part of a rail, and that's more or less 3, 4.5 or 6 meters, what you can see in the regulations in the infra managers. And what is then really the problem? The problem is you need welds to weld it together to continuously tack, and you don't like welds because they are not that good as mother material, And because you have a hard point inside, because of this difference of material, and you get a bump when you go over time. And a train has to roll and not bumping. So a weld is in that perspective not so good. But okay, we need them, otherwise we don't have continuously track. Why 3 meters? That's because of the frequency and the behaving of one wheel cycle. And one wheel cycle is running off on the rail. That means that you get these 3 meters, more or less, when you go over it. So therefore we don't like to have all kind of bumps or hard points because of welds. Another question I got from you was about monitoring by satellite. And there's a really new technique which is really good and also nice potential for you as a maintenance of track. Because what you can see in very detailed way is how track looks like and what the status is. So you can do maintenance far ahead that you can plan in, and that's really nice to see. I like to show again here, what we can see here is what we can have on the screen by the satellite data. The satellite is amazing and can see everything on the globe, and it's coming back every week. And what you can see is exactly the shape and the sinking track and the problems in the geometry. And you can see that for many purposes, and I think it's a nice addition for big data analysis. What we do is that we bring you some new literature, and you can see that already on the fora that we have sent you already some links. And what we like to give you personally, because you have a TU Delft ID, that you can see this by PDF. We bring this also on the website, and you can also read that yourself when you are more interested in this new technique. So I will find that and give it to you as a PDF. But be careful, it is personal and you cannot copy and send it away to other friends, because this is copyrighted, and only you, because you have a TU Delft ID, only you can use it. So good luck. So other questions I like to discuss with you, and therefore we are here in the laboratory of railway engineering at TU Delft, the Netherlands. So I was really wondering, how is it going on the on the discussions on the fora, on our website online. So I like to ask Valerie, maybe you can tell me what is ongoing already with the discussion.
Well, Rolf, good that you asked.
Okay.
The discussions are very good, very good. Many people are participating in that, and staff members also respond in that, and quite a few very interesting ones. For example, one question was about embedded rail structure.
Okay.
What is it? Does it have a future? Why it's not used very often and very wide?
It's a nice question. I think when you talk about embedded rail, the question is how much money you like to spend. I think that's the main issue, because when you have embedded rail, you have a long life cycle and with less maintenance, but you have to pay money and invest in the early beginning. And I think that's the real big question you have in mind. And do you like that? Okay, then you do. But when you have less money, and then it's better to have balanced track. Another way, when you have high speed, you need a very stable geometry, and therefore you need a very stiff construction. And therefore embedded rail is really what you need. For example, I have here an idea how this look like. And when you have here a cross section, then you see a goat with some embedded material and a profile. And this profile is really special because it is a very small one. Normally you need a high one because you need resistance against bending. And therefore you need a high rail, because otherwise you don't have this bending. And therefore this small rail helps, and it looks like it's not good, but this one helps to get rid of noise. And this noise is really low, and it will save you more than 3 dBA. And that's also nice, because we don't like noise in railway business. But we can have this low profile because you have a big resistance against bending because of the construction of embedded rail. Another way is that we have here with concrete, and we have blocks in between, and you can just make normal track, what we have here, as you can see outside. So you need just normal track. This looks like sleepers, but it is embedded in concrete plates, and these are blocks. You also melt them together with concrete. I think that's another way of embedded rail. This is what we use sometimes in tunnels in Holland. Here I see 2 specimens about embedded rail in a low profile and a high profile, and there you can see also the differences. But in stiffness, it could be the same when you make it in this construction. So Well, that's about that as well.
Thank you, Rolf. Yeah, now it's clear.
Okay.
Another topic which is takes a lot of attention of the students. It's a modular track.
Okay.
What is this actually? Can you please clarify a little bit?
Yeah, why not? I think modular track is really the future, because we need much more capacity on track, because that's also money, and also it must be robust, and a lot of capacity is also attracted because of maintenance. And maintenance, we don't have time for that in these days. So how to get rid of this maintenance? And therefore you need another way of maintenance. You need prediction maintenance, but also spare parts you have to be and replace it as quick as possible.
So you just take one block, replace it with the other one, and the malfunctioning one you can repair at the factory or something like that.
Yeah, I think that's also saving a lot of human hours, because now when something is broken, you always have to go outside in the track, by night, in the weekends, on holiday time. That's also nice for the people who has to do the maintenance. So it's better to do some idea how makes that kind of blocks. How can you make that, and what about the size? What is really good to move and how to move, because that's also another question. So there's a really big issue. What is the best block? How does it look like? And where do you cut it out in the real track, and how does it look?
So that's the problem is still how big they can be and how to transport them
yes.
to the track.
And I think also I have a nice message to you. Next week we have also a picture and also a movie how these kind of blocks are made in the factory. And that's all, you can see that next week.
Oh, you mean that switches and crossings?
Yes.
Oh, yeah.
So next week we will discuss switches and crossings. And I think this modular block system looks like. So I'd like to give you a question back. Please think about how these blocks look like and how big they are and how to transport them. There's always a nice balance in between, but you can think about it, and next week we will discuss it. So, see you.